What?
Today, I'm going to explain the internet better. Many people don't understand it, so I'm going to help them understand it. Many people think that the internet is just this slide page or many other stuff showing them, but it's a lot more detailed than that. So first, there's network connections, as you can see here. These are some possible connections. For example, in this one, this guy can only reach this person and this person, while this guy can reach this person, while this guy can reach this, and you get it. This is probably the best or this because one of them can reach everyone, and this is probably the worst. So there's three types of network connections. The first one is a local network connection. It's only working in a small area and it's usually working for schools or homes. So like if you go to an elementary school or like a middle school or a high school, you use local area network. It's abbreviated as LAN. So the second type is a wide area network. It extends through a geographical area like entire Australia, like the mainland of Australia, like the big part of it, could be could be a wide area network. It's usually made up of multiple, like a lot of local area networks lands, and no single company owns it. The third one is rare. It's the data center network, DNC, and it's for data centers, and it has fast internet speed data and reliable, because like those centers need like those reliable internet. Alright, so here is bitrate, bandwidth, and latency. Bitrate is how many bits can travel in 1 second. It's usually measured in MB or megabits, not megabytes. One, no, 8 bits is 1 byte. So, so yeah. Bandwidth is the maximum bit rate of a system, and it can't be faster than the speed of light because the fastest thing right now is the speed of light. The third is latency. It's the time it takes for a message to get to the other device. It's kind of like ping. Um, most always the more the worse because when it takes longer, it's usually worser. So here is Internet Protocol, IP address, and packets. Here is an IP address. Well, here are two types of IP addresses. The first one is IPv4, Internet Protocol version 4, I think. Um, so how it works is you there's this many different possibilities. Well, it's a group of four numbers. There's this many different possibilities, and each number can be 0 to 255. The maximum number is 4,294,967,296. This is a lot, but there's a lot more computers out there. So that's when the IPv4, I mean no, 6 came out. It's this is the max. F can be anywhere from 1 to 10 and A to Z. The max number is like a lot. So then there's IP packets. An IP packet has a header which is 20 or 24 bits long, and it also has the data. The data is the stuff you want to send. Like if I'm sending an email to my friend, Then where it's going to be, where I'm sending it and where it comes from is the header, and what I'm actually typing on it is the data. So, for example, on the Gmail, there's uh, no, like where to, that's the header. Uh, so now there's redundancy and fault tolerance. Redundancy is how many different paths are available. Like here, this is one router. If this is the place you are trying to send to, but it automatically shuts down for some reason, then you can still send to here and here. If this was not, like, if this wasn't there and this wasn't there, then you couldn't possibly, if like this wasn't here and this wasn't here, then you couldn't send your message to the other person, which is kind of bad. And and always the more the better. Um, Fault tolerance is a system that can experience multiple failures. Like here, this is fault tolerable. Usually, it has different paths for a message. Like here, it could go there, there, or there. Okay, so uh, now it's how the packet is sent between routers. So a router is like is like a connection thing you have at home. So here is a possible router connection. Okay, so here are the steps. First, you send to the first router. Then you see all the different router paths possible. For here, it's here and here. But then you see which one is the best fit. To do this, you have the IP you have the destination, and you see which one fits the destination. So here, pretend this is like 139. This is like 200, like 56. But this might be like 238. It's only one off. So this router would pick this one, and so on. So you repeat step number three until it arrives to the destination, which is here. So there are four types. Well, no, I mean, no, there are two types of internet, like sending, like just sending, like checkers, I guess. The first type is UDP, and it's um, it's the first one. The first 4 bytes is the location and where it's gonna be, like it's kind of like the IP header. And the second one is how much is stored, which means it can
Mm-hmm.
only be, which is 16 bits, which means that the maximum number is 65,535. It can only detect if the packet is added or nothing else. That's why it's kind of called the unreliable data packet or something. Um, TCP is the header can be from 20 to 60 bytes long, so it's longer than this. The header includes the source port number, the destination port number, and the checksum. This, in English words, is where it came from. This is where it's going to, and this is what I'm going to explain later. It does a three-way handshake before you can send the packet to see if it's okay to send the packet and if you can stop the connection. It can detect almost any problem with the packet. That's why it's better than this. But the reason why sometimes we use this is it's fast. For example, Zoom uses this because it's fast and we don't, but it might be unreliable. So thirdly, there's the checksum. So both UDP and TCP use the checksum. To get the checksum, you have to translate all the data into binary somehow. When the other person receives it, it makes another checksum of the data using the same method. If they match, that means the packet is good. If not, then the first computer deletes the packet and then somehow sends another one. So there's web protocol. So there's the domain name system. For example, I search up www.wikipedia.org and it sends me to this home page. When we look at it closer, there are three places like in between the dots. There's www, there's Wikipedia, and there's .org. So the three parts are called the third level domain, that's the www. There's a second level domain, that's the Wikipedia, and there's a top level domain, and that's the org. The top level domain is stuff like .com, .org, .edu, .net, e- uh, like anything with like dot and then after. Well, not anything, but like all of these. The second domain name is the name of the organization in the website. This is probably the English part. It's like the place, if you want to search it up on Google, then you'll probably get a link to the actual website. And the third level domain is usually www. It stands for World Wide Web. So now there's scalable systems. The definition of a scalable system is one that can continue functioning well even as it experiences higher usage. A lot of people use it every day. If a lot of people use it, it can still function as well. Some things that might go wrong for unscalable systems is bandwidth limitation. People with small bandwidth might have packets that might not go through. If a ton of people are sending stuff, your packet might take a long time to send, and by the time it sends, it might be useless already. The third thing that might go wrong is wireless routers have a limitation of people. It's usually 250. If any, so if you're at the library and you use a wireless router, there's going to be more than 250 at the library. Sometimes you can't send Gmails and stuff. Right. So the third, so thirdly, there's low testing. People like users, no, like founders of an app usually load test to see if the app can take the number of if it goes high above at all. So like for example, Pokemon Go. So before Pokemon the Go company thought that they could, but then uh, they actually got a bunch more people than they could. So then they started sending messages that said you can't play it. And then they had to fix it. So then they did. So they did not have a scalable system. So the last thing that I'm going to explain is the digital divide. The definition is that there is a difference between two people's use of internet. It might be more than two people, but it's usually two groups of people. For example, in Africa, there isn't a lot of technology, and the people might have a slower connection than people in the USA. Why? The first reason is that geographic area is bad for setting up routers. So if it's in a muddy swamp, if your village is in a muddy swamp, it's going to be hard trying to set up routers. Secondly, the government doesn't have a lot of money to. Like some governments are poor, so they don't spend their money on the routers. And number three, not many people there. There's not many people there, so the company who sells the routers make more money in urban areas, but they still but they still set up the same amount of routers. So here's an urban. No, I no. Here's an urban area, and here's the rural area. The rural area doesn't get like so pretend I'm the company of a company that sells routers. I'll get more money if I put it in there, but I'll get less money and if I get put it in there.
Mm-hmm.
So that's why usually rural areas don't have that much rural areas don't have that much routers in technology. Any questions?
Okay. Thank you, Charles. I have two questions. The first is on the slide, redundancy and fault tolerance.
Which slide?
I think it's 5 or 6. Yeah, redundancy and fault tolerance.
Alright.
Okay. So for this one, for the redundancy, on the second bullet point, you says the more the better. Does it have a threshold or limitation or the max number, or it just keep going to the infinity?
Just like if you have more connections to router, it's better. But
Mhm.
I don't
I
think
mean, yeah,
it.
I mean, the issue is like how many more I should have to be considered as better. So for the so so to annotate this, so if I have more, I have more, I be much better, or the graph is more like this. You know what I mean?
Well, like first, if you have two, that's good. But if you have a million,
Uh-huh.
that's you don't need that much.
Right. Yeah, yeah.
A million
Cool.
is
Yep.
only a little better than 1,000. But
Mm-hmm.
one is way worse than 1,000. So
Mm-hmm.
it's the second graph there.
Okay, great. So next question is on slide 2. Yep,
Okay.
network connections. So why you think this one and this one is the best?
No, I thought that this one and this one are the
Okay,
best.
okay. Or why is that?
Well, any of these people can send any other one of these message,
Okay.
so
So
that's
what's
good.
the assumption here? So for example, when I use this internet connection, so I'm sitting here, can I pass through this computer to connect this one?
No.
Oh, why is
Well,
that?
you may ask that the computer to send a message, but you just can't just ran through
Hmm.
the computer and just
Right. So here are the things. So this is a computer. This is computer. If this is a computer, then this network connection is bad because some computer could not connect with each other. So what I can do is if I replace the computer with the router, is it a better idea? If
yes.
I put a router over here. So the router is like everyone. So the router, the goal of the router is just routing the data to another, place. For example, a computer here send a message through the router. So the router will decide which destination you should go. But if we use computer, it's gonna be different. So can you imagine that like like person A send a really secret, like top secret message to this person, okay? And it passed through, some hacker's computer. It, isn't it terrible? Because the hacker didn't need to hack the computer. They just need to unreveal the message through here, right? Because the message passed to here. So the issues with this connection is more like security issues. Make sense?
Okay.
Okay. Okay. So computer is now used to or created to routing the data. Okay. Cool. Thank you, Charles.
Okay.
I'm gonna stop recording.